Hey guys, this is Unit 6, Lesson 8, Correlation Between Variables. We're going to work on estimation today. So how can you estimate the correlation coefficient? Examine the scatter plot and notice how it has a positive correlation. You can see that because it's sloping up from left to right, okay? The data has a positive trend. As the temperature, X values, increases, the number of beach visitors, Y values, also increases. You can now ask how close your R value is to the positive 1, okay? So that's asking how close are these dots to this line of best fit, okay? If the data fits perfectly on the line of best fit, then R equals 1. In this case, your data does not create a straight line through each of the data points. The data does not completely fit on the line of best fit. A few data points fall above and below the line of best fit. Because the data points are not very far from the line of best fit, you can estimate an R value of 0.9 or 0.8. This figure still represents a high level of correlation. The farther the data points lie outside of the line of best fit, the closer the estimate of the R value is to 0. The closer the R value is to 0, the lower the correlation. Okay, so the closer the dots are to the line, the closer it's to 1. The more spread out they are, the closer it is to 0 when we're dealing with a positive line. Okay, here's example number 1. You're asked to examine the data that a classroom teacher collected from students about how many days they were absent in the semester and their final grade in the class. You decide to plot this data on a coordinate plane in the first quadrant to better estimate the correlation coefficient. What would you estimate the correlation coefficient to be? We're going to work through this together. So unlike the previous scatter plot in this section, this data does not fit close to the line of best fit. These points are much further away, okay? Because this data produces a negative slope, you can see because it's going down when you go from left to right, okay? It's negative. The R value will be closer to -1 if the data has a strong correlation. So if all those dots are close to the line of best fit, it's going to be close to -1. But it's going to be a negative number no matter what because it is a negative slope. This data yields a negative correlation that is not weak, okay? The data points aren't like way spread out. They're kind of close-ish, so it's not weak. It's probably moderate. But estimating a -0.9 would be overstating how strong the correlation is. It's not, the dots aren't close to the line. They're not all tight in there, so it's not like -0.9 or -0.8. Like -0.7 would be a more accurate estimate because they're kind of spread out, but not like super spread out. If the data was even farther outside the line of best fit, a -0.6 or -0.5 would be a more accurate estimate, okay? Now, don't panic if you're looking at this and you're going, well, I would have said -0.5 or -0.6. It gives you options for all of the questions at the end of the lesson that you get graded on, and the options are very far apart, so it's a lot easier. It gives you the option of like, is this a 0.7 line or a 0.2 line? And it's like, well, 0.2 doesn't make much sense because it would be like a cloud, like all out here. You can just barely tell that it's a negative line. Here's example number 2. You're asked to examine the following 7 scatter plots covering various data sources. The scatter plots are organized in groups by the slope of the line of best fit. Based on the slope and what you have learned about correlation coefficient, you are asked to estimate the R value of each scatter plot. Using each line of best fit, you can determine which R values will be closer to 1 and which R values will be closer to -1. What would you estimate the correlation coefficients to be of the scatter plots? Now, again, your numbers may not be exactly what theirs are. Don't worry, it takes care of all of it at the end. This is just to show you general trends and what you should look at. So the first thing you should notice is that all of these 3 are negative because they're going down from left to right, okay? This one's obviously closest to the line, then this one, then this one. This one's the most spread out, okay? So this one is going to be closest to -1, and this is going to be furthest from -1. These 3 are all positive, closest to +1, furthest from +1, and this one has no trend line. I could draw a -1 or a +1 or a flat one. It's just completely random. There's no line of best fit. So the numbers they came up with for this one, they said this is about a negative 0.5, this is about a negative 0.9, and this one they're all on the line, so it's negative 1. Okay. For this one, they said positive 0.5, positive 0.9, and 1 because they're all on the line. And this one would be 0. When it's completely random, you're at 0, and there is no line of best fit. Okay. Here's a check-in. Which slope, positive, negative, 0, or undefined, would you associate with the line of best fit for a scatter plot with no correlation? So if you have no correlation whatsoever, is it going to have a positive? Is it going to be a positive line, a negative line, a 0 line, or undefined? It's going to be 0. Undefined doesn't exist. This is an example of a 0. When it's completely random, you don't know where to draw the line, you're going to have 0. Okay? Question number 1, it's your turn. This is a pretty quick lesson. Estimate the correlation coefficients for the following graphs. Okay? If you don't get the exact numbers that they get, it's okay, because it will take care of it at the end. So just go ahead and estimate what you think these correlation coefficients will be. Well, they're both negative. You can see that because of the slope. Okay? This one's going to be really close to negative 1 because it's a straight line. And this one they're saying is probably between negative 0.6 and negative 0.7. If you were anywhere except like negative 0.9 and negative 0.2, you're fine. Okay, as long as it was a negative number and it wasn't like really super close to negative 1 or really crazy far away, you're fine. Okay, don't worry, you're fine. Here's question number 2. What is the best estimated R value of the following scatter plot? This is what the questions are like at the end of the test. Okay, so take a minute and look at this and figure it out. Which one of these R values is going to be the most accurate? First thing we know is it's a positive slope, so a couple of these are going to be gone already. It can't be negative 0.5 and it can't be negative 0.9 because we have a positive slope. So is this closer to 0.2, which would be almost random, or 0.8, which is pretty close to the line? It's going to be 0.8 because if I draw a line right here, you can, sorry, that's not straight at all, but you can see they're reasonably close to the line. They're not clear out here and clear over here like they would be with a 0.2. Here's practice question 1. This is at the end of the lesson, so you'll want to write your answer down so that you can access it later. True or false, the scatter plot has an estimated correlation coefficient of negative 1. You tell me. They're all really close to the line, which means that they should be real close to 1 or negative 1, but this is a positive slope. So this is false. So you would type 2. Doesn't necessarily mean your answer is 2. They might shuffle this around a little bit, but that's how you would solve that problem. Here's practice question number 2. Which is a better R value estimate for the scatter plot? Negative 0.8 or negative 1? Well, it is a negative slope, so we want it to be a negative. The line would be somewhere in here, okay? So are they on the line? No, so it's not going to be negative 1. It's going to be negative 0.8. So for my question, I would type 1. This might be shuffled for you. Here's quick check question number 1. I won't give you these answers, but I will show you how to do it. It says use the data table to create a scatter plot. Estimate the correlation coefficient based on the data. So we're going to go to GeoGebra to do this. Okay, I'll show you how to do it. All right, this is just geogebra.com. So we're going to click Start Calculator. And we're going to go Table, because we have a table of information here we need to fill in. Our X values are 0, 2, 4, 6, 8, and 10. We're going to come over here and put in the corresponding data 2 values, which is 3, 6, 9, 12, 15, and 8. And it's totally fine that it labeled this Y1. That's absolutely fine. We're going to zoom out and look at our graph. Well, look at that. That's a beautiful little straight line. So it says, use the data table to create a scatter plot. Estimate the correlation coefficient based on the data. First thing we do is look and see, is it a positive or negative slope? Okay, and then we see how close is it to the line. You can do this. I believe in you. Here's quick check question number 2. Based on the data, which of the following choices would be the best estimated correlation coefficient? So again, look at your points, decide if it's a positive or negative, and then decide how close they are to sitting right on the line. Quick check question number 3. Based on the data, which of the following choices would be the best estimated correlation coefficient? Is it positive or negative? And then how close are they to the line? Are they right on the line? Are they close to the line? Are they reasonably close? And then figure it out. All right, let's move on to the next part of the lesson. This is example number 1. The data set examines the relationship between the number of hours a student spent practicing for their orchestra final exam, X values and input, and the score the students earned on their orchestra final exam, Y values and output. So the first thing they want you to do is create a scatter plot using the GeoGebra calculator. You're going to do the exact same thing we just did. Just open GeoGebra, click on table, and enter all these values. Okay, and then it wants us to use the regression feature of the technology tool to find the line of best fit. I'll show you how to do that. Got all my values inputted over here. Now we're just going to zoom out until we can see our plot. Oh, there they are. And now that I'm, got the area where they are, I'm going to zoom in a little bit more. I must have entered one of these wrong because this one is like clear out here. 64 and 90. Oh, no, not 6.4, I'm guessing is what it's supposed to be. Nope, 64, 90. Let's go see where I screwed this one up at. I need to go over. 90 is supposed to be 3.5. Well, that would explain why I totally screwed that up. Okay, there. That looks a little bit better. You gotta watch me, guys. I'm not very good at this. Okay, now we're going to use the regression feature of the technology tool to find the line of best fit. So to find the line of best fit, I'm going to my notes to figure this out. So we're going to go to, we got to scoot this out again. We're going to go to these 3 dots, and we're going to go to, I believe, this one. And find, what are we looking for? Line of best fit. I think I did the wrong one. Let's go back. Let's go here. I think I need this one. Does this one give me line of best fit? Nope. Okay, I'm on the wrong one. I can do this. I will get there. Oh, there we go. Okay. So we're going to go to regression, because see how it says use the regression tool? I'm so smart. Oh my gosh. So we're going to go plot, and then we're going to click on the line. I remember this now. Do our 2 A's, and we're going to put show value. And that's supposed to give us our, oh, there it is. It's clear down here. Hey, we don't want you clear down there. We want you to be part of this. Okay. This is our formula, but I don't know why it's making it so big, because my life is difficult. That's why. Okay. That's why. So there's our formula. Okay. So there's our line of best fit. And then it wants us to find the correlation coefficient. So to find the correlation coefficient, we now come to, we need my table back. We're coming here, and now we're going to y sub 1 statistics. We're going down to the correlation. There's our R value. Okay. So then if we come over here, we can see that our R value should be 0.92. And I got 0.86, so I probably entered another data thing wrong, but that's how you find the correlation coefficient. It wants to know how we find the residual value now. Okay, so the way you find the residual value is you do y minus y hat. Okay, so we have our y values, which are all right here, and then these are the actual values, and then we do it based on our line of best fit. Okay, so what it does is, let me come back over to where it's a better screen. Here's our formula for the line of best fit. So to find the residual, you're going to take y minus the y hat. Okay, so we have our actual y value based on what it should be based on the line of best fit. So our actual y value here is 61. So what I'd do is I'd go y equals 10.45 times our actual x value, I apologize, our actual x value, which is 1 plus 50.17, okay, which is then going to give us 10.45, because 10.45 times 1 is just 10.45, plus 50.17. So according to the line of best fit, when x equals 1, we should have 60.62, but we actually had 61. So our actual y value is 61, and we're going to take away the estimated value, which is 60.62. Okay? This is going to give us our residual. So 61 minus 60.62 gives us 0.38. There's our first residual value. This right here would be 0.38. Okay? You would do these steps for all of this table, and I really don't see how that's going to benefit you because, you know, that's just a lot of time and effort. So that's how you'd find the residual. Okay? Now it wants to know, in this data set, you decide to examine the point 377, which is right here. Okay, we're looking at this one, which has an actual y value of 77 when x equals 3. Use the equation of the line of best fit to find the residual when x equals 3. So what we're going to do is find the residual for this point. Okay, so we have y equals 10.45 times x, and our x value in this case is 3, plus 50.17. Okay, I'm going to grab my calculator, and we're going to go 10.45 times 3 gives us 31.35. To that, we're going to add 50.17, and that gives us 81.52. So the line of best fit says when x equals 3, y should equal 81.52, but y actually equaled 77. So to find our r value, we need to take 77 and subtract 81.52. So again, we're going to grab our calculator because I don't trust myself, and we're going to go 77 minus 81.52, and that's going to give us negative 4.52. Okay, so the residual for this data point is negative 4.52. Okay. It says negative 6.31. Let's see. Oh, 79. I wrote down they have a different thing, probably because I entered something wrong. Okay, but it's all the same steps, so it's okay. You know how to do it. Here is example number 2. Okay, imagine you're collecting data from your friends. You ask them how many people are in their family, the x value in the input. You then ask how much money on average they spend when their family goes out to dinner at a local restaurant, y value, and output. Use the GeoGebra regression feature of the technology tool. What is the line of best fit? So we'll do this again, and I'll try to be more careful putting in our information and see if I can get it right this time. First, let's get rid of our last problem. Okay, we're going to go table. Our x values are 2, 4, 4, 4, 5, 5, 5, 6, 6. Okay, let's get our y values. We have 66, 105, 99, 120, 100, 77, 169, 200, 176. Okay. Yeah, that doesn't work. There's supposed to be a way that you can zoom to fit to see all of your points. But of course, I can't figure it out because I'm a genius. Okay, so this is what our lines look like. And if I zoom out a lot, you'll be able to see my x and y values. Well, you should be able to. Anyway, this is what our line looks like. Okay, now we need to find the line of best fit. So we're going to go here. We're going to go regression. And our formula plot, boom, 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 and there's our formula. Okay, so it should be y is equal to 28. I'm rounding everything to the hundredths place, so 28.49x minus 6.2, round this up, 4. Okay, let's go see if that matches. Hey, 28.49x, 6.42 2, 4. Okay, we actually matched this time. I entered it correctly. We're going to examine the data point 2.66 and find the residual value. Okay, so here's our formula. We're going to take this point and plug it in. So we're going to have y is equal to 28.49 times x, which in this case is 2, minus 6.42. Calculator time. We're going to go clear, clear, clear. 28.49 times 2 gives us 56.98. Subtract 6.42, and that gives us 50.56. So what this tells us is that when x is equal to 2, the line of best fit says we should be at 50.56, but our actual value was 66. So to find the residual, we're going to take the expected value, subtract the actual value. Come here, calculator. 50.56 minus 66 will give us a negative 15.44 for the residual value. Okay, that's a really big residual, just so you know. So they said 15.26, but I don't care. What that means is that the data point lies 15.26 units above the line of best fit in the scatter plot. You can make this conclusion without examining the actual scatter plot. So now let's do 4 and 99. Okay, so we have y is equal to, I need my formula again, 28.49 times 4 minus 6.42, 6.42. Let's grab our calculator. We're going to have 28.49 times 4, 113.96 minus 6.42 gives us a value of 107.54. Now, we have to take our estimated value and subtract our actual value to find our residual. So 107.54 minus 99 gives us 8.54. Okay. So, and they're saying 8.72, but I don't care. Okay. This means that the second one is closer to the line of best fit than the first one was, because even though this one is negative 8.72, it's closer than the one that's 15.26. That's what they want you to get out of this. Don't stress about this, okay? Even without the R value in the scatter plot, you know, this data yields a non-perfect correlation. A perfect correlation would have a residual value of 0, because they would all be on the line. So using the x, y, sub 1 statistics feature of the GeoGebra calculator, what is the correlation coefficient? So let's come back over here to GeoGebra. And, oh, I was hoping it would work. It won't. To find our correlation coefficient, come here, scroll down, and the correlation coefficient is 0.7, and we would round it up to a 5. And it says 0.75. Okay. This value indicates a positive slope with the data points fitting loosely around the line of best fit. With an R value of 0.75, the residual values you found make sense. If the R value was higher, the residual values would be closer to 0 because they'd be more scattered out. This value would indicate that the data points are closer to the line of best fit. Let's move on to example 3. You decide to examine a small data set comparing the number of hours you have spent practicing the piano, X values and input, with the number of notes missed while playing the song for your upcoming piano recital, Y values and output. So first they want you to create a scatter plot using GeoGebra. So you just create a table, input this, you're going to get this. Okay, then you're going to use the regression feature of the technology tool to find the line of best fit. So you'll go to your table, go to Y sub 1, the 3 little dots, click on them and click regression. And then you're going to scroll down, and then you're going to click on the actual line and do the 2 A's and then show the value, and it will give you your formula. Okay. Then you're going to use the x, y sub 1 statistics feature to find the correlation coefficient. So you'll go back to y sub 1, click on the three dots, go to the x, y sub 1 statistics, then scroll down to find the correlation coefficient, and you'll find that your R value is negative 0.9958. The negative R value is very close to -1 and matches the close distribution of the data points to the negative slope line of best fit. You can see they're very close to the line. Okay, and then they want us to find the residual for each data point based on the table. Okay, so we got the formula clear back here when we did the regression feature. So you use the formula and the steps we did before to find our regression. If you need more help with this, comment and I'll make another video for example 3. Okay, and what does this table reveal about the residuals? Okay, 3 of the residual values are positive, meaning the points sit above the line of best fit, and 3 are negative, meaning they sit below the line of best fit. You can reasonably conclude that the linear model is appropriate. If you ever have a linear model come and everything is positive or everything is negative, something's wrong. It's not a good model. It's a no-no. Okay? You should have some above and some below. Question number 1, your turn. A line of best fit for a set of data has a correlation coefficient close to -1. Describe the residuals for the set of data. What are those residuals going to look like? For a correlation close to -1, the residuals are most likely small. So they're going to be little numbers, approximately evenly distributed above and below the line of regression, and do not lie in a pattern. Okay? If you didn't get this, don't worry, they don't ask you any of this garbage. Question number 2, suppose a data set has a very high correlation of R is equal to 0.9, but the residuals show a slightly curved pattern. Is the linear model the best representation of the data set? You'll have to think back to the last lesson to answer this. If the pattern is slightly curved, is it a good model? No, the curved pattern suggests that a linear model may not be the best representation of the data set. It has to be a straight line. Here is practice question number 3. Alex used a graphing tool to determine a linear trend line for his physics project data. The residuals he obtained were 0.15, -0.22, 0.31, and -0.18. What conclusions can Alex draw about the linear model's fit based on these residuals? The linear model is inappropriate. Well, they're not all positive or all negative, so it is appropriate. The residuals are too large to determine fit. Now, these are all pretty small residuals. The linear model fits the data well. Probably. The residuals suggest a nonlinear relationship. No, it's this one. There's nothing wrong with those residuals. Practice question number 4. Decide whether a linear model would be appropriate or inappropriate for each scenario. A data set has an R value of 0.95 and residuals that are randomly scattered around 0. Okay, so the R value of 0.95 means it's a positive slope, and residuals that are randomly scattered around 0 means that they're all pretty close to 0, so they're small numbers just like we saw here. Okay, so is this appropriate or inappropriate? This one's appropriate. The residuals of a linear model show a clear pattern, and the R value is 0.2. Okay, should we see a clear pattern in any of our residuals? No. Inappropriate. The residuals show no clear patterns, and the R value is 0.89. Yeah, there's nothing wrong with that. Your R value can be anything as long as it's between -1 and +1. The residuals are consistently negative, and the R value is 0.5. If they're all negative, you did something wrong. It's not a good model. Okay. Practice question number 5. Liam used statistical software to fit a linear model to his environmental science project data. The residuals he calculated were -0.12, -0.45, -0.33, and -0.27. What can Liam conclude about the appropriateness of the linear model based on these residuals? The residuals are too small to make any conclusion. No, small residuals are a good thing. The linear model is appropriate because the residual values are close to 0. It doesn't matter how far away they are from 0. That doesn't have anything to do with being appropriate or inappropriate. It's just how strong the relationship is. The linear model does not accurately represent the data because all of the residuals are negative. This one is correct. They're all negative. If you have all negative or all positive, it's not a good model. The residuals indicate a perfect fit. Nope, all residuals would be 0 if that was the case. Quick check question number 4. Jess used GeoGebra to find a linear model trend line of the data collected for their science project. They calculated the following residuals for their data: 0.26, 0.93, 0.5489, and 0.659. What conclusion can Jess make about the appropriateness of the linear model based on the residuals? Read through these and figure it out. You can do it. Okay. Jade was working on her statistics homework. One of the questions gave her a trend line and asked her to find the residuals. She found the following residuals: 2.6, 9.3, negative 5.489, and negative 6.59. What conclusions can Jade make about the linear model based on the residuals? Read through these and figure it out. Inspire change around you. Math is not for everyone. Don't listen to the liars that say everyone has a math brain, because they are lying.